Okay guys, so this is step 2. So this is the one where you do need a calculator, and same situation as last time. We'll do either a similar example or I'll tell you some things that will help you correct your problems in class. So, all right, in the problem 1, so write this down because it's going to help you when you try to redo the problem. They're telling you at the beginning that f of g of x is x and g of f of x equals x. This is a way of telling you that g and f are inverses because they reverse each other. Okay, so that's a good point to keep in mind when you're redoing the problem, but this is our similar problem. So if g is equal to h inverse, okay, so this means that they're inverses, and h of 2 is 3, and h prime of 2 is 5, find g of 3 and g prime of 3. Okay, now for this one, so you always ask yourself limit, derivative, or antiderivative. For g of 3, you don't need any of those things because if, okay, let me say it like this. Okay, let me say it like this. If g of x is equal to h inverse of x, and h of 2 equals 3, then g of 3 equals 2. All right, so the input and the output switch. Okay, so there is that. So there's that part. Now, for this part, limit, derivative, or antiderivative, this time you need a derivative. And we've got to use the inverse. Whenever you're dealing with inverse functions and you're asked to find the derivative of one of them, and you have information about the other, you've got to use the inverse derivative formula. So in this case, it goes like this. It goes g prime of x equals 1 over h prime of g of x. Okay, usually there's an f there. So we've got g prime of 3 is equal to 1 over h prime of g of 3, which is equal to 1 over h prime of g of 3 is 2. And then they gave us that. Okay, so there's that. Okay, now this one. I'm not going to do a similar example. I'm just going to give you this formula. The total distance traveled over an interval, this is something that we need to know. It's the integral from a to b of the absolute value of velocity. A lot of you just did regular velocity, but it's the absolute value of velocity for total distance. And then, so you set that up, you use that formula, and then you use Math 9, calculator required. Okay, now this one. At what value does f attain its maximum value on this closed interval if f prime of x equals cosine of x squared? So you ask yourself, limit, derivative, or antiderivative. We don't need to take any of those, but they're giving us a derivative, and we've got to use it and our knowledge of Susan's table to figure out, wait a minute. Huh. Actually, I would say antiderivative. Yeah. Okay. It would be antiderivative because, because this is a closed interval. Yeah, so we would want the candidates test. All right, so in the we do section, let's just go like this. Let's say that f of x, because this is what we want the maximum of, f of x is equal to, let's say, okay, so this is the interval that we're on. So let's just say f of 0, like whatever it is, plus the integral from 0 to x, and then cosine of w squared dw. Okay. Now we don't know what this is, okay? They didn't give this to us, so this is some number. And then this would be area under the derivative curve, okay? Yeah, so basically, guys, they want the maximum value of this. We're going to figure out where on this interval is the area under this curve the greatest. So I go to my calculator. I plotted it, or I graphed it already. And then I need to just really look at this interval. So from 0 to 3. So window 0 to 3. Okay. And I'd like to have a better view. So I'm going to change my window. Let's do the y min at -2 and the y max at +2. Okay. Now, so this is the area under the curve. So from 0 to this point, we're adding on positive area, okay? So up to this point, our area is increasing, okay? As you move further along here, the area is increasing because you're adding all of that. Yeah, you're adding all that positive area. But then at this point, the area starts decreasing because that's negative area. And then at this point, it starts increasing again, the area. And then at this point, it starts decreasing again. So we know for sure that, all right, so we're gaining positive area, negative, positive, negative. But guys, if you look at this, okay, so after this point, this is where the area starts to decrease after this point. And if you just kind of like ignore that, if you look at these 3 areas together, what do you think their sum is? What kind of number do you think their sum is? Well, this negative area looks bigger to me than this positive area. And even if it's not, once you add on this negative area, for sure, the negatives outweigh this positive, all right? So here you've got this positive area, and then for the rest of it, you'd be like basically subtracting something from it. So at this point is where the maximum value must occur. All right. Okay, so let's just write for our notes, use graph and compare areas. Okay, and we get max at, okay, so once you realize like where your maximum value occurs, which is here, then you've got to find it. So I go like this, 0, left bound, right bound, enter. So there it is, 1.2533. Wait. X equals 1.253. Yeah, 4 decimal places. Okay. Number 4. You can do that one. Okay, so I'm not even going to say anything. I'm just going to let you think about it when you're in class. This one, we're not going to do a similar example. I'm just going to tell you that this is a related rates problem. You need like a no, want, when chart, and then you got to do implicit differentiation. And then exam topics to look for, number 9. Okay, see first salmon packet, number 9. Okay, so see that if you need help. Now let's do this next one. Okay, so you're going to have to write all that down. So we're doing a similar example. So we've got all of this. Okay, so write that down. Duh, I shouldn't even be, you could pause it. And I'm pausing. Okay, so you've got the integral from 2 to 8 of f is 1. The integral from 2 to 8 of 5g of x is 15. And the integral from 5 to 8 of the sum of f and g is 10. what is the value of the integral from 2 to 5 of the sum of f and g? Well, first you've got to look at these intervals. And you've got to say to yourself, which intervals are the parts and which interval is the whole thing? 2 to 8 is the whole interval. 2 to 5 is one part of it, and 5 to 8 is another part of it. So you're being asked to find a part, and a part of this overall area, I guess. And you're given already the other part of that overall area. So if you just find, so here, if we find the integral from 2 to 8 of that sum, because 2 to 8 is the whole interval, then we can subtract this part from it and we should end up getting that one. Okay, so we know this, but then this is not exactly just the integral of g. It's the integral of 5g. So let's write this down. So the integral from 2 to 8 of 5 g of x, this is equal to 15, okay? But you could always pull a constant multiple out front. So this is the same as 5, integral from 2 to 8, g of x. Okay? And just like you would do in like regular algebra, you divide both sides by that. So you get that the integral from 2 to 8 of g of x dx equals 3. Okay, so you could be like, therefore, the integral from 2 to 8, I'm going to stop using so many parentheses inside. So I like the parentheses because I think it makes the whole input thing more explicit, but sometimes it's a lot to write. Okay, this is 1, that's 3, so that's 4. Right? Yeah. But guys, this, the way you do this, you can go, this is called the additivity. No, maybe it's called it. I forget what it's called, but you can go like this. Okay, so that's equal to 4. All right. So you've got that this is 10, and then you've got that this is 4, and then you want this. So basically, guys, you're just going to subtract 10 and 4. And you could stop taking notes now if that's clear, but I'll keep going if that's not clear. All right, so basically you have, okay, so the integral from 5 to 8. All right, let me do this is not good notation, but it's easy to do this because it's multiple choice. So we got the integral from 5 to 8. Oh, let's go over here. Okay, so the integral from 2 to 5 plus the integral from 5 to 8 is equal to the integral from 2 to 8. Okay? From 2 to 5, this is what we want. From 5 to 8, they gave us that was 10. And then we got that this is 4. All right? So you just subtract 10 from both sides. So I'll be like, therefore, the integral from 2 to 5 equals -6. Alrighty. So there's that. And guys, we are basically done because you can do this one. You can do this. Use Susan's table. All right, I'll talk to you later.